Okay. Oh, I think I should start my Audacity one. So let me just start my send. Just thinking. Guys, I have to put my Audacity on before I start this video, because my Audacity has to be on. Oh, it's still going. Okay, it's fine. So basically, this Audacity is really running. I didn't stop it. Good. Okay, basically, guys, this is the Gussie Labs repository. I haven't really got to the other poem, but there's two poems in the stanza. So you got the first stanza, which is Rifter's Way. Now the Gussie Lang is the other stanza. But should be. Let me try to find it first, but I don't want to find it now. Okay, let me just start. Basically, I don't want to find it. Basically, here we got this Gussie, the world's first poly got programming language. This is Gussie Labs. You experiment with Gussie Lang, which is why it's called Gussie Labs here. So we got the MVP, but that's what I want to talk about the projects here. So we got like the V, which stands for Vision. GitHub openings V. Now go MVP, which is a minimum viable product. But I don't dive into the MVP here. I want to dive into something else. Which is the docs. Now, hope the docs is good enough to read for myself. So you got the docs in two forms. You got the manifesto. You got the Gussie Lang manifesto. Oh yes, it's a manifesto. Yes. Basically, this guy, yes, is one. So basically, this is the Gussie Lang manifesto. You basically got the Rift manifesto in Gussie Lang. So we are the thread keepers. We are the thread keepers. Basically, we write code that breathes with patience through the night sleeps. We build bind trace and never race race condition. Because race condition is like something that's racing to solve a solution and then crashes because it's running. Basically, it's an async issue over concurrency and parallel execution because they're racing for data information, and one comes to that, and the system gets basically we bind threads that never race. That's a race condition. They never race. Never panic, never ghost, never leaves us behind. Never panic, they never exit for no reason. We're sorry, not sorry about our standards. Basically, it's a policy and system. This is version 1. Sorry, not sorry, hashtag hack, human advocacy compliance cycle. So you got this policy. I'm sorry for my work. I'm not sorry for your work. So you give me dirty work. I'm sorry for my work will be dirty or rubbish. This is your work. So if I have to give you back your work, so to solve your problem. If I'm happy taking your work, and you got a no ghosting policy, you can't leave the project. It's like something that is important. You really committed to it. So you have to follow through to it. We are human alliance country. Basically, this is just this code. This is human advocacy compliance cycle. But that can be human aligned critical. Yeah, I don't know. It's basically the advocacy systems for the systems based on the thing. But this just like hack policy can be a human ad lib, but human advocacy. Human should advocate for each compliance of the cycle of the project cycle. Okay, this example implementation. The code direction. Thread optional is not thread safety is not optional. Thread safety is not optional. Basically, this is example code. An actor at actor underscore safety critical level equals max. The maximum level can be the 0 to the 1 to the point earlier. What I'm saying to you is that the error is safety critical. It's a value strategy, based on A-star scoring. The scoring is algorithm. A-star scoring is very important for me because you can update it. Basically, you're going to something called a error cycle. You're going to have something called update. A-star is a short update. When I want to have a download from a server that's downloading the shortest part to update to my system based on my time scale, everything I'm working on, and so I can get the latest commit from our system. So basically, this can actor. Okay, so this is like an actor. An actor is an actuator. It acts on behalf. Basically, it's like a structured class. It's like it can structure data information, and then that actor model is acts on the behalf of that information that's really got to resolve. Every thread is paying, owned, isolated. No risk condition, no deadlocks, no exceptions. A bit flip should never online for patient. Just like because when I sleep on my machine, we're not apologetic for. We're not apologizing for compile time, thread safety and performance. Basically, this is a poem I'm gonna write, but concurrency is not care. So basically, concurrency is care, not competition. Basically concurrency is like two things using asynchronous time application. Basically, no mutex, no data, no mutex, no mutex, no shared data, no logs, just listening. basically you got a message bi-directional message passing. But what meters do is they allow you to mutate data, store muted data or muted data. But that's the problem because if something that's mutated, it can get corrupted and you can get something that's not mutated. That's not what you want, but anyway you want to see it. That's what I'm saying. Because if you have muted data, the mutex should keep the data isomorphic to the original information, and you can pass through a lot of message channels and a lot of polyglot systems, and again, you can decohere naturally. You can lose information. So basically, there's no mutex, there's no locks, there's no just listening. So basically, the actor of the patient's model is state isolated. The hardware affords a state for isolated. Basically, it's an isolated message passing system. The system doesn't really need to talk to get a message. If it gets a message, it doesn't. It's basically read, write, execute. Am I right to read this message? Am I right to write this message? Am I right to a constant time verified this like a fresh and breathe. This function never returns, it remains, it holds, it binds. It's just like for the thing. Sorry, no, sorry, reject lock based. All locks, nothing should be locked, in systems, It's basically, I'm trying to remove all the whole, things of locking and semaphores, that's what this is, I'm rethinking, rebuilding safety critical systems, they're not meant to they're not meant to be. I'm thinking outside the box basically. That's why Gossilang exists. It's basically meant to remove all that nonsense. That I speak. I have a sleep machine. I can't show you here, but I have a sleep machine. And if that machine crashes at night, I can die if I don't get breath. So I'm not even using it. I do use other things. Competition, no care, no competition. Basically, this function breathe never. Because basically, the at constant time decorator is verified when the breathe function works. Basically, this like a constant time is just over. So this the person should always breathing. It should be always no locks on the data. For the breathing. It's scaring me. So this is something that I would use. If I build it with my own silicon. Uh, oh yes, we do not ghost our threads. At the policy, no ghosting. You can't ghost a thread. What a thread kills itself or gets like you don't ghost that thread. You find out why that thread was limited using rollback animation. You can find out this policy ensures that the system is coherent. Like timing attacks artisan failures. Anything that's timed out times out. That's like a system has to basically the login thing. Basically, you have like something. Basically, if it's a message, if I see a message that's takes n time to compute, login should be the message pattern sequence. If the architecture is coherent, the structure of the architecture, the system should never take more time than it actually needs to pass. Basically, if the protocol starts off, if the protocol starts to communicate at login, half the time of the message, then the message will go through because it's very connected. By the time the message even starts, what I'm saying to you, that kind of time attack can really break the system because if you lock something, thread, you have to redesign it. Memory is sacred, not shared. Memory is like the token type, token memory. Anything that's in memory has to be a replica emission. So you ensure that you don't fragment the system. But the isolated actor of the buffer for basically a buffer of never exists because the safety boundary is that the memory is the red black to black. Based on what it needs and what it wants to do in that current time frame. It's like a perception membrane of its own action. It's like watching its own state. We own our memory, we don't share it. Memory is if it's temporary memory, we can share it, but we don't share with the right people. We never we own it. We own it, we borrow it, and so basically we own it because we own it already. We borrow it. We want to borrow more memory, more space. And we or rent it, like rent to buy, own it, share, own it, borrow it, or lend it. We lend memory. We lend space for other people. But that's the structure of the system. So basically, the system boundary is memory sacred. We don't basically every bit you have, if you have like a 4 bytes of memory, 4 bytes is 8 times 4. That let me go calculator. 8 times 4, 4 times 8 is 28. 28. That's 8 bytes. In segments. 28 bytes in photos, but that's 8 bytes segment, which is like sorry, no, 8 bits, 1 byte segment. That's 1 byte, 1 times 8 bits. Basically, there's way to channel this memory, but memory is sacred. You have to ensure that the pool of memory of the structure is because basically we get memory, you're using the memory actively. You don't let anybody else use it. Based on the red black animation strategy, which means the computer is like you're using it and it's gonna get printed out because you need fresh memory, and then your memory can be restarted of the program, redact because memory is sacred. So basically, Hardware is third, etc. etc. I can't really show you this video here. Sorry guys. Good, good. Study, not study. Basically, sorry, not surgery, actor-based model, compound time, critical fast. It's like to the developer, respect you, to the patients, to the industries. But this is a guarantee of the system. We don't ensure that the explicit recovery. But sorry, not sorry. Just keep threading. There's a there is then you are going. If you write code, keep patient breathing through that. If you actually care about what you write, think about it. You writing a code for your son or something like that. Use Gussie Lang. You care about what you're building. You care about the sustainability of your ecosystem. You care about what like handicraft. Like hand. If you care about what you're weaving, the program. It's about care. That's what Gussie Lang represents. It's not about the bureaucracy, the talking, the slow progress of life. It's about the big change in the overall making, and your action, your actor, you want to do, take initiative to using the wheel framework to do it. Okay, now, so basically, I'm gonna type column file. I'm gonna just try to explain it to you. But this I can do this now. If it stops error in me, MD this one. Basically, basically this is an element actually just like a discovery system. Now this is in simply language model atlas system. Basically it's like it's based on the language discovery framework, which is like a NLM underscore framework, which stands for Insibila model. Basically the S. I don't talk about this right now. But I'll come. You can read the documentations here. Minimal. Basically, minimal Gussie routine. Anything else, guys? I want to read here before I start. So basically, I'm gonna look at some code in Gussie Lang now. Knowledge base MVP V. Now you go to V. Basically, this is the GitHub that comes with V. AVO hybrid structure. Okay, guys. Phenoblock. So we go like Gussie. Now let's look at some code. We go like MVP Gussie. Let's try one. First, let's get Gussie P 01. This is the first invitation of it. Now we're gonna look at the Gussie Lexa, which is just a test.js file. Now this is the file format test.js. So you go like let v equals basically this is sample one. So let capital V colon equals not vec. Now this let is the tokenizer. Basically you don't have a var in it, and then we got like v equals some kind of a variable that's entangled. Now v is a vector of 3D vector vec3. Now you get equals using basically it's a macro vector. So the macro, the exclamation mark, small vec vec, and then a bracket 3, right angle brackets 3, number 3, and the left angle brackets equals the basically saying create this v, set v, the v to equals 24 or comma 26 to the 4 3 using a tuple. So basically you got a tuple in there, but it's a vector of a tuple. So it's like direct construction of a Phenomolgicel model. Basically it's what it is. Basically you don't have to create instance of instance. You have to really just get the data. So using the word operators, which is what you need to do, because the system just the type system is so flexible. You just get the data. I'm gonna run this file here, but let everything in the universe equals same 42. Now bind v everything to v. Now basically this is just like entanglement. So basically I can now perform the binding, which is like a binding, which is a policy, but the policy is like a bound. Because it's like a policy execution. Basically it's like you go like the at, which is the kinds of policies everything, and you go the policies where the function relate, and now this hashtag bind colon everything comma v bind everything to v. Now everything basically 41. If you want to perform an operation on this 41 minus 24, you get 24. No, basically you're gonna do 41 minus. So let me do my pen. Basically, you can do like any operation that you want on it, coherence operation, like a union of it. So you can get like 41 minus 24. How much is that? 3, 1, 12 minus 4 is 8. 8, 9, 10. And then 34. 34, and then 42 minus, basically 42 minus 6 is what? 38. And then 38 will be 38, 38, 4. And then 42 minus 4 is 40. So you can get 38, 38, 40. That will be the new V. If you want to output as a result, or output it as a function, because really the binding just makes it bound. It's not a method. So you get V, a new V, which is just a translation of the everything using Phenomolgicel related principle, which is one example I'll give you. So that's basically, if you bind everything there, you have to have to get it out. So you can print V to see what V is. V is a macro, because the goal of this example is the gossipy idea of minimalist design. Try to go here outside the box. Yeah, let me just try to run this program. It should just basically, I'm gonna run this program for you guys here. Let's see what it brings out to you. But it should be a coherent answer. It should be something for you guys to able to evaluate. This is Gussie Labs here. So I'm going to my terminal on my screen. Guys, can't wait to show you what the result is first. Come on, Namdi. Sorry. So basically, you can have like a minus, add, because you just bound it to the value. Basically, it's like superposition, entanglement, and interference, coherence, in modeling to ensure that the system understands what it's doing on the fly. It doesn't really need to depend on the structure of the data, because the structure is the phenomenology itself that is thinking about, and the operation is just abstract. The operation is just not even there. You can use a union if it's a union model, if you're modeling a set. But if you just numbers you're involved with, you can do like anything related to number theory. That is not a set. It's like I'm trying to get this thing up. My terminal. Okay, my terminal is not responding. Okay, let me just take this charger off. So basically, I'm gonna just turn my phone. So I'm gonna run this file. I'm gonna show you what I see here. Here, come on, MD. So I'm waiting for the file to load. Okay, it's really load. It's dropped frames, 17 minutes, and I've literally just okay, basically, my terminal is still loading. Come on, MD, come on. Come on. Guys, this is like taking so long to load. I don't think I can pause it now. Oh, it's crashed. I think it's crashed, guys. Okay. Let's just try now. Guys, my mouse is so slow. It's so annoying me. Oh. Come on, guys. Because basically, I have to start recording. But I think I have to go to the next video. But I'm gonna stop this video because it's like really annoying me. I don't just stop it. I don't just stop it now because it's like a control OS. So let me just try to stop it now. Guys, let's try to stop this video. Control Alt Shift O. I'm trying to find a shortcut for it to stop it. I don't really know. guys, basically, I think I'll go to Structure Manager. Let's close because I'm trying to stop this video so after like. So guys, it's not quite. I have to stop this video in a minute. Okay, let's try to move it. Let me stop this video. Okay, basically, I can't even upload anything now. Let me just close my camera. Just able to hear me to stop this video. Come on, Namdi. Let me just try to sign out. No.